Have you ever thought about the secret language that powers pretty much everything? From your phone's GPS to the video games you play? It's not code, not exactly. It's more like a universal translator for space itself, a way of giving every single point in the universe a secret address. Today we're diving deep into the world of coordinate geometry. So, to get our heads around this, let's start with a game we all know, Battleship, right? When you call out D4, what are you actually doing? You're using a simple grid, a coordinate system, to pinpoint one exact spot. It seems so basic, but that one core idea, it's revolutionary. Because what that game of Battleship really does is give every single point a unique address. And this fundamental concept is the key that unlocked one of the most powerful tools in all of mathematics, a tool that literally bridged two completely different worlds. But, how did we even get here? To really appreciate the breakthrough, you have to understand that for centuries, math was basically split into two separate kingdoms. On one side, you had geometry, all the visual, intuitive stuff, shapes, points, lines. On the other side, you had algebra, the logical, precise language of numbers and equations. And for the longest time, they spoke completely different languages. They just didn't talk to each other. Well, that all changed back in the 17th century. A French philosopher and mathematician, a guy named René Descartes, asked this incredible, groundbreaking question. What if we could use the language of algebra to describe the world of geometry? And bam, just like that, coordinate geometry was born, creating a universal translator between shapes and numbers. Now, to make this translation actually work, Descartes needed a map. He needed a stage where algebra and geometry could finally meet face to face. And the solution was the Cartesian plane. Just think of it like a map made from two number lines that cross at a right angle. The horizontal one, that's our x-axis. The vertical one is the y-axis. And the spot where they meet, that's the most important landmark of all, the origin, which has the address 0, 0. So now, every single point on this map gets a unique address, what we call an ordered pair, like x, y. And there's this great little way to remember how to find any spot. You always start at the origin, you move along the corridor, that's your x value, and then you go up or down the stairs. That's your y value. It's simple, it's elegant, and it is unbelievably powerful. Okay, now for the real magic. Once we can plot points like this, we can do something absolutely incredible. We can turn these abstract rules from algebra into visible, actual shapes. And this is the key idea right here. An equation isn't just some problem you have to solve. It's more like a recipe or a set of instructions. You could even think of it as the algebraic DNA that holds the blueprint for a specific shape. So let's take a really simple rule. An equation like this one, y equals 2x plus 1. Right now it's just symbols, but this equation is holding a secret picture inside of it. And all we have to do is follow the instructions to see it. So how does the rule reveal the shape? It's actually pretty simple. We just plug in a value for x, and the equation tells us the value for y. So if x is 1, y is 3. That gives us the point 1, 3. If x is 2, y is 5, giving us point 2, 5. And if we plot all the infinite points that obey this one simple rule, they all line up perfectly to form a straight line. The algebra has literally become a picture. In this new language, well, it comes with a super powerful toolkit. For instance, the distance formula, it actually uses the Pythagorean theorem to find the exact distance between any 2 points on the map. The midpoint formula lets us find the dead center of any line segment, no guessing. And the slope formula, it tells us a line's exact steepness. With tools like these, we can analyze any shape with total mathematical precision. It's amazing.
But here's the thing. This isn't just for textbooks. This secret language is the invisible engine humming behind the technology that shapes our modern world. It builds, well, just about everything.
And it all starts with our own planet. The grid of latitude and longitude, that's a giant coordinate system for the Earth. The equator is basically our x-axis, and the prime meridian is our y-axis. Every single location on the globe has its own unique address. This global grid is what makes your GPS possible. Using a process called trilateration, satellites use distance to find you. The first satellite narrows your position down to a sphere. A second one narrows it to the circle where those two spheres overlap. A third satellite narrows that circle down to just 2 possible points. And a fourth one confirms the correct point. It's pure coordinate geometry in action, happening in your pocket. 100%. What's that?
That's the percentage of digital screens that are, at their very core, just coordinate grids. Every single tiny pixel on your phone, your tablet, your computer, it has its own X, Y address. And that little fact is the entire foundation of our digital world. In a video game, a character's position is just its coordinate. Movement? That's simply the game updating those coordinates really, really fast. And how does a game know when you've hit a wall? It uses the distance formula to check if your coordinates are getting too close to the wall's coordinates. It's all happening behind the scenes.
The applications stretch way out into our physical world, too. Architects use computer-aided design, or CAD, where every single point of a skyscraper is defined by exact coordinates. And for air traffic controllers, the sky is a massive 3D grid, where every single airplane is tracked as a point in space, all to make sure everyone stays safe. So it's pretty clear this is so much more than just another math topic, right? It's a fundamental shift in how we understand and actually interact with the world all around us. And on top of all that, it's the bedrock for almost all higher-level math. I mean, fields like calculus, which is the mathematics of change, would be almost impossible to even study without the visual stage that the Cartesian plane gives us. When you get right down to it, coordinate geometry isn't just a grid on a piece of paper. It's a lens. It's a special lens that lets us see the hidden mathematical patterns that govern the very space we all live in. It's the ultimate translator. It takes our physical, visual world and converts it into the precise, logical language of mathematics. And with that language, we suddenly gain the power to not only analyze our world, but to design and build entirely new ones from the ground up. I mean, think about it. From a simple game of Battleship to mapping the entire cosmos, it all comes down to giving space an address. So, now that you have a little glimpse into this secret language, what kind of new worlds could you imagine building with it?